Here again with the next chapter, mensuration. But before that, let's go here and so last session we were discussing about this one: how many faces, edges, and vertices does a pyramid have? So if you come here, pyramid with n-sided polygon. So if you say this is the pyramid with n-sided polygon, how many faces are there? Faces are going to be for n-sided polygon equal to n faces plus the base 1, n plus 1 faces. Um, Vertices going to be again n-sided polygon have n vertices and then plus 1, so n plus 1 vertices. And then edges are going to be um, for the base polygon, the number of n polygon means n edges plus these all. For every edge it will create the side edges, so 2n of the edges would be there. So we come here, this is what going to be update. Earlier I was confused this pyramid with prism, so the data was wrong, but now it's correct. Now coming to next, here we are going to study the next chapter. Let me All right, this is mensuration. It's nothing but measurement. So whatever we studied so far, or we know so far what is two-dimensional, what is three-dimensional, solid shapes are three-dimensional, two-dimensional are 2D shapes, rectangle, quadrilateral, and all, and triangle kind of stuff. So um, now we will apply that knowledge to measure area volume of these shapes. So let's start. What is it? Mensuration is nothing but measurement of various parameters of geometric figures, like two-dimensional, three-dimensional parameters like perimeter, area, and volume. Perimeter is used for two-dimensional, area is used for three-dimensional, volume is used for three-dimensional. Area is also used for both two-dimensional and three-dimensional. So we will study some of the common 2D and 3D. 2D means D stands for dimensional. 2D are called some examples we can give. 2D are rectangle, trapezium, rhombus, circle. We have touched on these earlier, but we will revisit them with respect to measurements. 3D examples: cuboid, cube, cylinder, pyramid, and cone. So cube means all sides same, cuboid doesn't have all sides same, cylinder you already know, we will see a figure again, pyramid we just studied this kind of a pyramid is, and then cone also we saw it's kind of non-polyhedron or something like that. So for 2D we will measure area and perimeter, for 3D we will measure area and volume. 2D figures, so these are the formulas you need to remember, trust me, to do all the calculations. So this is for 2D and you will see another table for 3D. Okay, so what is it? So first one in this category is circle. Circle's area you might have studied earlier, um, pi r square. Okay, so pi r square means where pi, you know, pi's value, r means radius, so pi r square is the area of the circle. And here we do not have example of circle, but circle you know already. First one I missed, it is a triangle. Triangle, you know, triangle figure is here. The area is half base multiplied to the height is the area, and perimeter is easy for two dimensional, so that's why I haven't mentioned here. So perimeter anyway is kind of sum of the sides. So we will just, for 2D we will just study the area. Parallelogram, what is parallelogram? Parallelogram's area is they have parallel sides, so base into height is the area of the parallelogram. For trapezium it's a little tricky, half into height plus multiplied by half into height multiplied by sum of the parallel sides. So this is how it is for the trapezium one, where so these are the parallel sides, B and A. So it is going to be half multiplied by H multiplied by A plus B. So that's how it is. You can figure it out yourself, or see some reference online how the area of trapezium is calculated. You can check in book if it is there, but online you can get it out. So it's nothing but so in this case it's nothing but area of the three pieces. One is this these two side rectangles, and then this middle, this is going to be a square. So altogether it is evaluated to so and so. Quadrilateral. So this is a quadrilateral where its area going to be area both sides of this diagonal, this one and this one. So there are two rectangles formed by this diagonal. So the area is going to be half multiplied by one diagonal, because that's what is taken, and then sum of the perpendiculars to that diagonal. So it is easier to do it. So you just figure out the area of individual triangles and then sum them out. So it is going to be so. It is also same as kind of trapezium, but in a different way. Okay, rhombus. So rhombus, rhombus is kind of a uniform kite. Kite is a separate shape. Rhombus is a uniform kind of, where half multiplied by diagonal 1 by diagonal 2 is kind of rhombus. And then for polygon, this is a polygon with yeah. So for polygon, the area is going to be sum of the area of the pieces. So per se, what are the pieces? Per se, in this case, it is given. Okay, this is the part, one rectangle. This is one rectangle. So sum of this and that. So this is also a polygon. Polygon can have also five edges or six edges. So irrespective of how many edges are given, you draw the diagonals, and how many pieces are formed. Just sum all the areas of the pieces. That is going to be the area of the polygon. Polygon is a very vast shape topic, so it is measured by piece by piece. We will see one example of polygon area. Yeah, so rhombus diagram is missing here, but already you studied in the quadrilaterals and triangle, you already know. Now, these are the main three figures we will study for this 3D figures, where we will see the surface area and volume. Cuboid, cuboid is something which is going to have different dimensions for length, height, and base. Where cube is having same dimensions for length, height, and base. Cylinder will have a radius and a height. Okay. So for cuboid, the surface area is going to be um, right, surface area of all the six faces. So now the faces are repeating twice, so that's why it's factored out twice, 2 multiplied by LB plus BH plus LH. So that's how going to be the surface area. And volume is again, three dimensions are given. LBH, multiply all the three dimensions is the volume. Cube also same thing. um, Sum the surface area of six faces, and then volume is going to be L cube. Cylinder, same. um, Cylinder's area is going to be what is the area of a cylinder? Perimeter of the base and height. So surface area is going to be uh, one is the here one circle, top and there is one circle, bottom one circle is there, and the lateral surface is there. So for two circles, the surface area is going to be pi r square plus pi r square, that is 2 pi r square. So I have factored it out there. And then lateral surface is going to be perimeter of one of the circle and height. That's the area of the lateral surface. So that is 2 pi r h. So clubbed together, it is 2 pi r we have factored out, and then r plus h, that is going to be the cylinder's surface area. And then volume is easier. So just circle area multiplied by the height of the cylinder, which is kind easily understood, that that's going to be the volume. Okay, now examples. Okay, here we have one example we are going to see. Okay, is a typical example. What is the area of this garden? This garden is going to be two semicircles at the end and one rectangle. So just sum it out and you will get the area. Okay. Rectangle in the middle has dimensions given, so semicircles you will figure it out, and then you add all the both the semicircles and the rectangles area. It is turning out to be so and so. This is how going to be the problems coming. What is the surface area of a cuboid, where cuboid is given so and so. So volume is given, LV is given. We need to first figure out what is the edge, and for cuboid the surface area is 2LB plus HL plus BH. So you can do, so you can easily get what is, those are the kind of typical questions. Find the area of this quadrilateral. What would the area of this quadrilateral? You got a diagonal here, and then that makes two rectangles. So sum of this rectangle to sum of this rectangle is the total area of the quadrilateral. Okay, this is what it is saying here. The perpendiculars are given, the diagonal is given, so you can easily calculate. Okay, so half base into height, half base into height, both add them and you will get. What is the algebraic expression for the area of a wall to be painted? So this is what it is given, the values in x, and you need to figure out what is the area of the surface to be painted. What is the area of the surface to be painted? You are not going to paint the door and window, so figure out the area of the whole 2D figure, and subtract from there the area of the door and window. Okay, and that's what total area minus the area of door and window, and this is what going to come. Okay, what is the area or OD of a polygon? Okay, so this is a polygon, and it has 1 2 3 4 5 6, so six sides are there, and what is the area of this? That's the question. So it is just showing here that where diagonal AD and its perpendiculars are given. So AD is given, its total length is given, and the perpendiculars to AD is given. So you will just make it bits and pieces. So this rectangle plus this rectangle plus sorry, this triangle plus this rectangle plus this triangle, maybe this is a rectangle or a quadrilateral, and then this is also a triangle. You can see that there are four triangles and there are two quadrilaterals, so just sum it out and then you will get it. So what it is giving is that we know AD, and the position of these points are given. Q, P, N, and M are given on this here. How far they are from A, they are given. So that gives us the base dimension, and then height you can evaluate. So area equal to sum of the four triangles plus two trapeziums. Saying this is called a trapezium or a quadrilateral. So just add them up. I have calculated it here. This triangle, so after you put these points here and measure, this triangle's area is going to be so and so, this trapezium's area is so and so, this trapezium's area is so and so, this triangle's area is so and so, and this triangle. So in this kind of a problem where AD is given and the points over here is given, so we figure out individual what are the shapes going to form for rectangles, two trapeziums, and figure out each one's dimension by subtracting, adding or subtracting from here and there the point distances, and then you will form the individual areas and sum them out, and that is going to be. So this is kind of one of the problems you may get. Calculation wise a little happy, but this is also a possibility. You need to practice more from the book. Next one is a syrup bottle is a cylinder shape with its diameter so and so and height so. So what's the volume? Easy. Just put the formula. We already studied. What's a cylinder? The volume is going to be pi r square h. Just put it out and you're done. So practice more, guys, and that's the catch. We will meet it in the next chapter. Practice all the exercises, and then only you can able to be expert in mensuration topic. Thank you.